Hello YouTube, and welcome to the second video in the tutorial series of making an agent-based distributed manufacturing model, where we're creating a set of machine agents who are then connecting with a set of job agents who then negotiate and bid and broker for work. In the last episode we just set up like the global environment, so setting in global time, created our broker agent, which acts as like the representative of our server in a real world system, and then a base agent class and a set of message types that we're going to be sending across the broker. So in this video we'll be creating the job and then a machine agent. So to start, we'll start with that job agent. So we'll go to models, job.ts, and we'll export a class job and extends agent. Spell, there we go, agent. And I'll import that from our agent model. And remember to put the JS in there. So that'll import our agent. So job is going to inherit all the functionality of our base agent model. We're going to have set a status. And this is actually going to be of a type enum. Enum job states. So we're going to have the job exist in either an available state, it's either going to be selected, or it's going to be completed. So the simple workflow for a job is to go from available to selected to then completed. And we will start with here. We say status is of type job states, and we're going to give it, when we create the agent from the start, job states.available. So our jobs default to available as soon as they get created. We're also going to add submission time. And that's going to be a number, and that's going to be given on creation. We're going to have a print time, which is also a number, so how long it's going to take to print. Machine ID, that's also going to be a number, and we'll set that to -1, so that will be used to store which machine actually selected a job, so we can interrogate that once the simulation is completed. Completed time, then it's going to be a number, and then set to -1, so only changed, updated when it is actually completed. And those are all the variables that we're going to add, and you can imagine in adding much more detail about a job, such as volume, the type of material it's using, to extend the information and the job definition. We then construct that job. So this is when we instantiate it with new. So we're going to pass it a new ID. We're going to give it print time, and we're also going to use, of course, remember we've got to set that debug. We're going to boolean equal it to false. It's always going to default to false unless we set to true. We then need to do a super init. So we're going to say agent types dot job. So we're going to say give it the ID from the constructor. We're going to say it's of types job, and we're going to then pass the debug flag through, so the base agent class has knowledge of that. This submission time will then be given as global time. So when we create it, so on creation, we'll set that as the submission time. And of course, we need to then set the print time as the print time that we've passed through the agent. And as before, we have a next function, and because we are not doing anything every loop with the job is actually just going to be listening out for messages and responding to events in this instance. We can leave it out of this one, because in the agent the default is just an empty next function that does no operation. What we could do is just the one that we want to overwrite is actually handle message. So it's already Notice that we've got that from the original class. Now, effectively, what we're going to do is overwrite that with the custom logic for the job. So we're going to say this dot message received is +1. So we've received the message if this gets called, and of course that message is received type is created in that agent class there. And so we still inherit those variables, so that's why they appear here as well. And if we go if this.debug, then we'll just then console.log, and we can then say job. We're just going to tell us that this job, this ID has received a message. Oops, the $sign but before. Keep shortcutting and opening up other folders. There we go. This.id, and we're going to say has received the message. $sign message dot subject, so we can get the idea of what the message is. And actually this says message of any, we know it's of type message that we're going to receive through that. There we go. So we can import message.js. And now we're going to create a switch statement, and we're going to have message.subject. So based on the subject, we're going to respond in different ways. Now the first case we're going to look at is then the message type. Okay, is machine is looking for jobs, and we can then do a check if or we can equally put this out of its function if we wish to, just to try and keep it clean. And we can do this is say machine looking for jobs response. And what we can do is then create that as a function and call it in here. This dot message machine is looking for jobs, new message, pass it the message, update this one as well. There we go. So it's expecting a type message. Break there, and we'll also just add the default response. In this case, we should never reach the default response. We'll only respond to messages that we've got the logic for. So if we do, we take method to handle message not implemented, and we will process .exit. So we know something's gone wrong with our code, because we should have all the methods to respond to the messages that we'd expect for the job. So it may be that it's received a message of a type that we shouldn't expect to see. So we'll just exit there. So then for the machine is looking for jobs response, we will then create that response. It's going to be of type message. We will take the thread ID, so we can then keep track of the responses per agent. Message.from. So now we're going swapping. It's going to the person it's come from this.id, so from us, and send at global time. That's going to send, let's say +1. So it's going to be the next loop where the broker should pass this on. Agent type is going to be the agent the agent type that it should be going to. Of course, it's going to be a machine, because we should only be responding to machines in this instance. Subject is message type. Message types dot job is available. So what whoops, that will wrap up if, of course, if this dot status equals job states dot available. So we'll only respond to the request if we are available, and we will send this response. In all other cases, we'll just be a silent actor and not actually report any feedback. So then we'll do broker.receive. Oops. Oh, we need to attach the broker. So from last time, we were going to attach it, but I forgot to do that. So we've got a broker here. We need to do broker. Define that. Oops, should import. There we go. So we've imported that broker because all the agents should have access to that broker. And we will have this function here. Do broker.connect this, broker.connect this. So we should then connect to the broker, and we will then define this dot broker as broker. So on the creation, we're going to have to attach the agent, so simulating that idea of connecting to a server in the real world. Okay, so that's then we should come back into this into the job agent, and now we should have the broker available to us. And if we do receive, there we go, we get the receive method, and it will receive our response. There's another variable we need to add, which is going to be the body. And in this case, we're going to send it a print time. Of course, it's dot print time. So there we go. So we're going to send it the print time. So we're going to, I'm available, and this is how long I'm going to take. And then we're going to building some logics for those responses in the machine. The next case we need to deal with is message types dot machine has chosen a job, and we will then add the logic down here. Chosen a job response. And again, that's going to accept the message. And there we go. So then we can just add that into our function up here. This message chosen job response, and pass it the message. Great. And in this case, we just need to check if we are still available. So we go if this dot status. Well, to be fair, we could do another switch statement here, just to, it's a useful tool for this. So this switch, it's dot status. In the case that we are job states dot available, break default break. Start up. So if we're available, we are going to if debug is on, let's stop debug, then we're just going to write a little console.log and say job this.id has accepted message.from. So it's accepted, we've accepted this machine to print this job. We'll then do const response type message, and same as before. If I just copy and paste most of that up the top. So we're going to keep the message thread. We're going to respond to the machine that we've added to. We are then saying it's from us in the next time step, and we are now going to say machine job has accepted machine's offer, And again, we're going to pass it the print time, so the machine knows how long we're going to take, and we're going to then send broker will receive this response, and then we then become this status gets selected, job states got selected, so we're now in a selected state. The other case, which is like the default, any other situation, we will then say, let's copy that response again. And, oops, sorry. Let's call that R2 for now. R2, call on R1. And so in this message, we're going to say job has declined offer, and we're not going to have anything in our body. Just have an empty body. And this.broker, and that response to. No need to change the status, but then that machine will know, well, we've already been selected or something's happened. You continue on with what you need to do. So that's machine has chosen the job. And then we've got the last one is case message types job complete. There you go. Break out of it once we're done, and so then we need to create the function. I'll just put it up here so it's easier to see together. Complete response, accept the message, type message, and actually we're not having to respond to anything in this case. We're just going to just update the status. So we just say job complete response, pass the message through, although that we don't necessarily need to, and it'll probably well, actually we do need that to say when we were completed that. So job states dot complete, and this dot completed time equals message dot body dot completed time, or completed at. So this is going to be a variable that we'll add to that body for that specific message. Then this dot broker dot disconnect. So we're going to simulate us just disconnecting from the network. This and yeah, it's going to be this agent. So we're going to use the completed at from the message body, because before we talked about the idea of lag and introducing the lag into the system. So you might imagine that, yeah, we could have used the global time at the time they received the message, but if we had added some like default lag of like 5 seconds, then we'd be off when the actual job was completed on the machine side. So we take it from the actual message body, and that is the full instantiation of the job. So it's a set of responses to machine questions. Now it's a case of, so we can just create a couple of those in our experiment just to test it out. So we've created our broker. I'll just pull up my example, and let's create a set of jobs. So we'll just create a jobs array, or type job, and start it as empty. And then for let I equals 0, let's create, here we go, maybe a couple of jobs in this case. I++. We can create a print time, and we can do some kind of random time. So let's do math floor dot random. We can say multiply it by an arbitrary number, by yeah, 5 maybe. And then we'll always just add one to have not jobs without 0 time. And then we'll create a new, create the job using that. So new job. We need to create an ID for them. So let's just have a number for our ID system. Call it N, and we'll give it N. Print sign. And we're going to say we are true because we want to listen out for the logs for the debugging. And we're going to connect to the broker in almost like it's in time 0. So we'll create that. And we'll also just add it to our array of jobs. So when we wanted to do the for loop, and if we wanted to do the next command, we could then iterate through all that jobs list. And we'll increment the ID for the jobs and the machines. So if we did pnpm experiment 01 again, and run that, that's it. It goes and runs our 99 steps. And at the top is, before we even start running those 100 time steps, we've got at 0 time, job 0 is connected to the broker. So the broker's reporting the logs because we've set that to debug to true. And in here, we haven't activated any logs because they're only in the handle message function. So that's our job. And how are we doing for time? All good. Okay, so we'll continue on and create the machine agent. So machine.ts, and it's very similar to the process of creating the job agent. We will have some states that the machine can exist in. It could either be available, it could either be waiting for responses, we need to put the comma up there. It could also be in waiting for acceptance. So it may have made that decision of which job to go for, and it's just waiting to hear whether the job has accepted its request. Or it's busy. So busy, i.e. busy printing a job. And as before, so we create the class, export machine, extends agent. Write it a bit slower so I can get the automatic import. Again, just remember that the JS to bring in. So then this machine is also going to have status, machine states, machine states dot available. We're going to have a variable called current job. Current job will be -1, so that will update throughout the simulation as new jobs get selected. Jobs brokered. It's going to be an array of numbers. It's going to be start as empty, so those are going to be all the jobs that we build up over time that we've printed throughout the simulation. Responses is going to be of type message. So that's going to just store the response, the messages that we receive after asking the jobs if they're available. There we go. Response thread ID. Going to be a string. We'll start it as empty. So whenever we start a conversation, because the machines are the instigators in this example, we'll create a unique ID for that thread and we'll store it here. Wait. Going to get a number. Default it to -1, so that's how long the machine will wait to collect responses before then taking an action. Rejections, just a metric for us as we analyze our agent-based network, just how many times it got rejected by jobs. And then we're going to introduce a function called logic, and it's going to be a type number. So we're going to we'll create a set of logics such as first come first serve, longest print time, shortest print time, that then the machine will use once it's got its responses as to which job to select. So in the constructor, we'll give it an ID of number, so it gets a new ID. We'll receive that logic. It's going to be a function and a number. And then we're going to get debug. It's going to be boolean default to false. Now we do our super init ID agent types dot machine and pass through the debug. And this logic, we'll call the logic that we pass through. Not the log, there we go. And that's it, that's created instantiated the machine. Now in the machine's case, we will have a next function, and we'll also have a handle message function. So here in the next, so we will be iterating, constantly updating the machines every iteration. If this.debug, console.log, find out what the global time is. Oops. Global time. Machine of this.id as called the next function, and we're going to find out what its status is. Status. And then it's another set of switch case statements. So switch this.status, and we're going to say in the case that machine states dot available, we are going to go this responses. Let's do a function as we did before, so we'll call this next available. Again, these could be any name you wish. So this next available. Break out of that, and let's do the default as well. Break. There we go. So next available, we're going to say these responses, we're going to just reinitialize, so machine is ready to go and look for jobs. So we're going to set this.wait equals the global time, plus let's do +5, so it's going to wait for 5 time steps before debating those responses. We're going to set a response thread ID as random UID. We get that from the inbuilt crypto library, and we're going to then change our status to machine states dot waiting for responses. We're going to create a message to send to the broker. Thread this dot response thread ID from this.id and 2, and as I said before, we will set that to -1 when we want to send it to all the agents in the address book of a particular type. So we need to find out what that type is, and we want to define it as agent types dot job So send this message to all the jobs. Send at global time +1, so the next time step. And the subject matter is going to be message types dot machine is looking for jobs. And the body content is empty. And then we go this broker receive our message. Okay, so that's next available. The next case is waiting for responses. Okay, let's bring that across here. And what we want to do is then, as before, create another function down here just to keep it nice and neat and tidy. So going next, waiting for responses. And in this one, we just want to say if not this dot wait not equal to global time, and we can return. Else we will continue down to say if this dot debug console log will print out say something like, let's say, global time machine, its ID, and is we're going to say is deciding on responses. Okay. What we want to do is first of all do invalid responses number an array, and it's going to be an empty array. So what we're going to do, because not in this demo but in other ones where we do have lag, you may have responses that are from different threads, and it may have stored in that response list. So what we want to do is just capture those and ignore those in our list of valid responses. So we want to go of this dot responses dot entries. So we're going to loop through our entries, check that the message thread, if it's not equal to this response thread ID, then we'll push that into the invalid response list. We'll get that ID in there. Okay. So we're just getting a list of response IDs, and then we're going to sort those. So those are the indexes, right, in that array. Just going to sort those. Okay, B minus A. And then we're going to splice them, so take them out of the response array. So get the index of the invalid response list, invalid responses. There we go. And we're just going to go this responses splice IDX +1. So we're going to just remove them from the response list. But if all is good, we want to again do response ID this dot logic. So we're going to get it to run the logic that we're going to define here later on. So we're going to pass it a logic like first come first serve. It's going to run that. It's going to return an ID, which will be the the print or the job that it wants, and we'll do a double check. If the ID greater than equals to 0, then we will respond to that with a machine as selected. So we'll just update the machine states dot waiting for acceptance, and then we go message, type message, and here we go, we've got a thread. We'll get that this dot thread ID so we can keep track of the to and fro's with this thread of discussion. It's from this ID to the ID that we return from the logic. Send at global time +1 agent types dot job, so it should be a job, and the subject is message types dot machine has chosen a job with an empty body, sending nobody, and that's 2 ID there. Then we go this dot broker dot receive that message. Now we send that to the broker. Else we will go into this status of machines available again. So we haven't been able to find a job that's suitable for us. We go into the available state. We then will reset our response list, and this dot wait will just default it to -1. So when we go to next in the loop, it will reset our let's go and search for more jobs. The next one is case machine states dot waiting for acceptance, and that's just break. We just let it loop. So we're hoping to hear back from the job. And there's another one, case machine states dot busy. So we've selected the job, we just now need to iterate as we're printing and manufacturing. So we just need to create the next busy function, and we can put that into the next busy. And in here we just go this current job decrement by 1, because actually the current job's going to store the print time, and we're going to decrease that print time until it arrives at 0. So then we go if, so we've decremented it, and then we go if this dot current job equals 0, so we've reached completion, and this dot current job -1, so oops, equals -1. So effectively we've removed it back to a default state. This dot status, we now have become available again to get another job, and we are now going to send a message, and I'm just going to borrow one from before, and it's going to have the response ID, this ID, this dot jobs brokered, and it's going to take this dot jobs brokered dot -1. So it's going to get the ID of the last job that we brokered. We'll send that in the next time step to the job, and we will say job complete. So we'll tell the job it's completed. It will then update its own status, and we'll just then in this dot broker dot receive this message. And that is all the functionality for the next function. So ultimately, these kind of logics and agent-based models all revolve around these different states and performing those next steps within a time loop. So that's what we've got here, and then all the functionality for each of those states. We also have the handle message function that we need to update. So this is because we're going to receive messages back from our agents, our job agents basically. So then we'll just go this dot message received +1. And I'm just double checking where I haven't. I should also on these ones here just do this dot message sent +1. This dot message sent +1. And the next one here, this dot message sent +1. So we're just recording every time we're sending messages to as a metric that we're interested in. Now we do if this dot debug we will just so we've received the message, so console.log and we can again just give it a time step of when we receive that message. Machine list.id received message message.subject. So what did it receive? And then we get to a switch case statement again. And this what we're interested in again is the message.subject and then handling different subjects. So one case it's going to be the message types dot job is available. And then all we're going to do is this dot responses push the message. So we're going to add it to our response list. We'll break. We'll also add our default break. Process exit because we shouldn't have got here. Should not have. Let's put a proper one in there. Method has not been handled. Message, not method. There we go. So we can start to debug that. Case message types dot job has accepted machine's offer. This dot status machine states dot busy. This dot current job equals message dot body dot print time. So we've accepted. So the job has accepted it. So we're going to now go into printing mode. We're going to set the current job's print time to current job. Jobs brokered dot push message dot from. So we get the from ID, and then this dot responses will empty as well and break from that. Again, these could all be in separate functions, but because we're not doing too much logic here, I've just decided to keep them in the same switch statement. Dot job has declined machine's offer, and then this dot rejections 1. This dot status equals machine dots available. So we'll go back into well, machine must that job was busy or it's been selected whilst it was waiting for us. Therefore, we'll just go back and become available again and look for more jobs in the next iteration. There we go. It's all responses empty, and then we'll break from that as well. And that is the set of messages that we need to handle. And that is the rest of the the machine. The only thing that we're missing is the way of instantiating it with a logic. And to do that, we'll create a logics.ts file where we're going to create our machine logics. I think just for this case, we're just going to do tfs this.machine type number. Oh, bear with me 2 seconds. Okay, back. So where we're just creating that logic fcfs. So this is first comes first serve. So we export a function, first come first serve machine. It's going to accept this type of machine, so it's aware that it's going to be part of the machine class. You need to import that JS as well, and it's going to respond with a number. And what we're going to do, because we've cleaned up that responses list, we just go response.length equals 0. Oops. Stop responses.length. If this responses.length equals 0, then we will return a -1. So there's no ID to pick from. If not, we're just going to select the first one in the list. So this responses 0, first index from, and we'll give that one back. So now we've got a simple logic that we'd attach to that machine to select the jobs from. So with all those together, we can now add our machines to our little example simulation. So we'll do const machines, machine type machine. Again, it's going to be an array and it's going to be empty. And we're just going to create a single machine to handle those couple of jobs. So we can just do say const machine equals new machine, but you can imagine us doing a for loop just like the jobs to create a set of machines. I'll give it the ID of n because we've been incrementing it before. We will give it the first come first serve logic, so we've imported it at that top there and it's given it to the machine, and then this is how we can add all different types of logic and see how they compete or self-organize. And then we're going to say true, that we're going to debug and see what happens to that machine through the simulation. We're going to connect to the broker and pass it the broker, and we're then going to do machines.push. We're going to add it to our machines array. There we go. And not really needed here, but we can increment n again. So you could imagine then having a loop of machines that we just wrap the loop around that bit of syntax. So now we've got the broker is running its operations, but before that we want to do then imagine looping through the machines. So for machine of machines, and then we can do machine.next. So this would be if all goes well, we will create 2 jobs, create the machine, and then as it starts, the machine will look for jobs. They will respond. It will take the first one that it responded to, and then do that printing, and then pick the next job following that. So let's see what happens. There we go. So we've got lots of waiting for responses, looking for jobs, mainly because we've run much longer than the jobs that we have available. So if we go to the start here, we've got job 0 is connected, job 1 connected, machine 2 is connected, all in time 0. Then machine 2 goes to next, so looking for available, and then the next time step it's saying waiting for responses. It then receives the responses job 0 and job 1, saying machine is looking for jobs. And then we go into machine 2, the next, waiting for responses. It also has received the messages job is available, so the jobs have responded. They would be appended to the response list, and then we go waiting for responses because of that 5 time step timeout. Then we're on to deciding responses. It then has selected a job, the job is accepted, and then it has received the offer, and then we're into the busy mode of printing. And then it keeps printing that until we get into, here we go, busy, busy, busy. Then it goes into the available mode, and off we go again, trying to find the next jobs. So that's all that there is really to us setting up an initial model for our agent-based logics. Now, the one things that we're missing here is a bit of randomness, and we can add that by shuffling when the machines are called on the next function here. So in this array, we have created them in a nice single order, and we're calling them in that single order. So the next thing we'd do is just to shuffle that, and same with the jobs, we can shuffle that. So you'd shuffle those each time step and then run the next functions for the operations. So hopefully that gives you a good flavour of how we're doing our agent-based modelling. Please leave in any comments if you want any more information or go into any more detail. I can build this out to be a bit more complete if you'd like, but hopefully I'll get you started, and thank you for watching. Bye bye.